Okay, we have a graph here. Now, is this a graph of a power function? Well, I'm going to say no, but you're going to have to take my word for it, at least for right now. Okay, so it isn't a power function. It's a little hard to test it for reasons that I'm not going to detail here, just because of the position and the extent of the graph. You only can do about one doubling from the left point to the right, and that handicaps us a little bit, but if we know a little more about power functions, we'll be able to test it. Another thing is, one characteristic of this graph that I've specified here is that the slope first becomes 0 here at a point that we label point Z. So the graph has a negative slope, but that negative slope is becoming less and less negative. Actually, that negative slope is approaching 0, coming up from the negatives towards 0. And I'm specifying this as the point at which the slope first becomes 0. Now, I'm going to go through 3 transformations that will transform this into a function that might possibly be a power function and that we can easily test to see whether it's a power function. Okay, so the first thing we could do is we could shift the graph horizontally until the point Z is on the y-axis. Now that simply means we have to shift the graph over here so that the point Z is now here. Now we really can't call that point Z anymore, so I'm going to call that Z with an apostrophe. Call it Z prime. And the prime can have many meanings. It could mean the slope of the graph of a function, as we've seen. But right now it simply means the position of the original point Z after the transformation. Okay, so we could just pick a couple more points on this curve and transform those points. Okay, let's see. This point is this far to the left of this one. So I'm going to say we have to move over about this far, and we end up with a point about here. So if I do my horizontal line and do an arrow indicating the horizontal displacement, this arrow should have the same length as this arrow. And I could do the same thing, and I think I'll get a point, maybe about here. So now there are 3 points on my graph, and I can connect them. Something didn't look right, but it's okay. Okay, so now here is the graph shifted horizontally until the point Z is on the y-axis. I'm calling that point Z prime. Now, next thing I want to do is I want to shift the graph vertically until that original point Z, the point that we got here, it's now our point Z prime. But when I wrote out the questions, I didn't have the prime notation, and something I just introduced. So the vertical transformation will be through this displacement, and that's going to put this point down here at the origin. Okay, so I'm going to use that same transformation. It's going to lower this point to here, and again lower this point to about here, so that now we can sketch the graph. And this is the graph that we would get if I've done this accurately, which I certainly probably haven't. If I just grab this graph here, keep it in the same vertical horizontal orientation, and just move this point down to here, this is the graph that I'm going to get. And it makes a certain amount of sense if you look at the graph that's the way it would turn out. Okay, well then I want to do one more transformation where I reflect this graph through the y-axis. Okay, well, of course the origin is on the y-axis, so its reflection is itself. This point will reflection equal distance on the other side, putting it about here. And at this point we'll do the same thing, and that's going to put it about here. And now I can sketch a graph through those 3 points. And naturally, these are only representative points, and the curves are not exact. None of the constructions have been exact. You could do a much better construction using a compass and a straight edge. So now my question is this graph a power function? Okay, I think you understand how I constructed this graph, and now you should test it to see if you think it's a power function.